Hi, this is Group 32 presenting the video of our BTech project. I am Mizanullah, IPG 2013-066.
Myself Sumit, IPG 2013 111.
Myself Yogesh, 2013, IPG 126.
Also, let me introduce our supervisors who have been instrumental in successful completion of this project. Ajay sir and Pradeep sir. But before we begin, let me narrate a true incident. In 2008, an 18-year-old boy in California posted, Steve Jobs had a heart attack. On CNN, I report. What was the result? Apple lost $4.8 billion in the first hour of trade, which almost amounts to 10% of the value of the company. So, what was the root cause of this huge loss? A simple rumor. And this is what our BTB is about, modeling spread of rumor through emails. Objectives of the project are to investigate how rumor is spread through emails and developing a theoretical model to mimic the behavior of the spread of rumor through emails. Now let us see how exactly we did it. So we divided the entire population into three different parts. The first part is spreader, denoted by S of T. Spreaders actively spread the rumor. The second part is ignorant, denoted by I of T, and they are not savvy to the rumor. The third part of the population is Stifler, who knows the rumor but has stopped imparting in wake of informing someone as of recently informed. Now, when a spreader meets an ignorant, the ignorant turns into a spreader. It can be denoted by this differential equation. The ignorant population turns into spreader population at the rate of sigma. When a spreader meets a Stifler, the spreader turns into a Stifler. The same can be denoted by this differential equation. The spreader population turns into Stifler population at the rate of beta. Whereas when a Stifler meets an ignorant, there is no effect on either part. Summing up, we get the following ordinary differential equations. The negative sign here indicates the decline in the population. We've used the fourth order Runge-Kutta method. Now to know the behavior of the population, we assume the following values. Sigma equals 0.7, beta equals 0.3. The initial values of spreader, ignorant, and Stifler population are 1, 479, and 20 respectively. Now putting these values in the differential equations that we obtained above and treating them as an input into our ODE45 solver of MATLAB using the following code, we get the following graph as an output. So we can see that ignorants are continuously decreasing, Stiflers are continuously increasing, and spreaders first increase and then they decrease. Now let us analyze by observing the nature when changing the values of variables. Keeping sigma constant at 0.7 and increasing beta, we can see in the graphs that the peak of spreader is decreasing. Keeping beta constant at 0.4 and increasing sigma, we can see in the graph that the peak of the graph is increasing. For fuzzification, we have used the following equations. The peak of the graphs of spreaders, ignorants, and Stiflers denote the respective populations at time t is equal to 0.1, 0.3, and 0.5. Now we compare the crisp values that we obtained before fuzzification and the defuzzified values. Upon comparison, we found out that they have almost similar CV and DV values. Since our result is now verified by fuzzification, our rumor spreading model is successfully verified. Now let's see the significance of our project. Discovering rumors and then minimizing them using the concept of mitigators. Uncovering the most effective way to spread data rapidly over a network. and understanding how to prevent the flow of misinformation online. Thanks a lot. Hope you enjoyed this video.